Hi, Assalamualaikum and good evening. Today we will present our project Signal and System. Let me introduce the members of my group. First, there is me, Juliana Natasha. Next is Nur Sarah Damira, followed by Shaidatul Farhana, and finally Nurul Natasha. Here is the content we will presenting today. Introduction, convolution of voice dimensional signal, Fourier series, fast Fourier transform, FFT, convolution of image filtering, and lastly, conclusion. This project explored the principle of convolution and Fourier analysis through hands-on simulation and practical application in MATLAB, enabling students to develop technical and creative skills in signal image processing. Participants will demonstrate their ability to operate technical devices for audio recording and image capturing to obtain high-quality audio and image, while applying advanced techniques such as convolution of voice dimensional signal, Fourier series analysis, fast Fourier transform, and image filtering method. Additionally, students will showcase activity and technical expertise by composing and synthesizing music through the manipulation of harmonic and sinusoidal signal. The project further emphasizes proficiency in using MATLAB as a powerful tool for analyzing and manipulating audio and image, fostering both technical and artistic growth.
Hi and Assalamualaikum. My name is Nur Natasha. So today I will explain about convolution. Convolution combines signals and filters to modify data. In audio processing, it used for filtering, reverb, and effects. In image processing, it enables edge detection, blurring, and sharpening with kernels like Sobel and Gaussian. Convolution enhance or suppress features to modify signals and image. For image filter modifies pixel values to achieve effects like noise reduction and edge enhancement. First point, low pass filters blur by removing high frequencies. Second point is high pass filters enhance edge by suppressing low frequency. Third point is bandpass filters is solid specific frequency range for texture or pattern analysis. The last one is filters operate in the spatial domain, which is convolution or frequency domain using FFT. Next, Fourier series decompose a periodic signal into a sum of sinusoidal components, which is sine and cosine function at different frequencies, amplitudes, and phases. This is useful for analyzing signals in the frequency domain, identify harmonic content, and reconstructing the original from its component. It applies primarily to periodic signals. Last, the fast Fourier transform. The FFT is an algorithm to compute the discrete Fourier transform, which is DFT. Efficiently, it transforms signals from the time domain to the frequency domain, providing a presentation of the signal's frequency component. Unlike Fourier series, FFT works for both periodic and non-periodic signals, making it ideal for spectrum analysis, filtering, and signal compression.
In this project, I will present task 1, which is convolution of voice dimensional signal. To complete task 1, we record the voice all of the members say their names and use MATLAB to process the audio. We convolve the recordings with an impulse response of our choice and noted the challenge we face. During the demo, we will play the original recording, the impulse response, and the convolution output while also displaying their waveform to comparison. For the coding part, we refer the link provided in the assignment. We needed to convert the recorded voice to a .wav file format to ensure MATLAB could recognize the input. Next, we made observation and identify some problems we encountered. While running the code in MATLAB, we observed the following error. On line 167, the error indicated that the specific file name was not found, followed by similar issue on line 190. On line 2, the function autoread could not detect the file due an incorrect file name. Here is the result of the
Hi, my
coding
name is
output.
Juliana
You can
Natasha
click the play
binti
button
Clemenya.
to hear the audio
Hi,
output.
my name is Nur
Here
Sarah
is the
Damira
result
binti
of the
Hamdi.
coding output. You can click the
Hai,
play
my name is
button
Syahidatul
to hear
Fahana
the
binti
audio output.
Mazaizal.
Here is the result
Hai,
of
my
the
name
coding
is Nur
output.
Natasha
You can
binti
click
Ahmad
the play
Maswah.
button to hear the audio output.
Hi,
Here
my
is the
name is
result of
Juliana
the coding
Natasha
output.
binti
You
Clemenya.
can click the play button
Hi,
to
my
hear
name
the
is Nur
audio
Sarah
output.
Damira binti Hamdad.
Here is the result of the coding
Hai, my
output.
name is
You can
Syahidatul
click the
Fahana
play
binti
button to
Mazaizal.
hear the audio output.
Hai, my name
Here
is
is
Nur
the result
Natasha
of the
binti
coding
Ahmad
output.
Maswah.
You can click. This is the result of the audio waveform display visually on the MATLAB.
Assalamualaikum and hi, my name is Nur Sarah Damira and I will present to you the second task. For this task involved on creating a 10-second song using sinusoidal harmonics, and I will playing them and displaying their sine waves using MATLAB. We also have included the MATLAB code provided in figure 1 to generate harmonics and write some of our own code. Now, I will demonstrate how I accomplish my second task in this coding MATLAB, which involve downloading a song, editing it to 10 seconds, and implementing 5 harmonics to make it a complete song. So the first step was to find a song and download it, an audio format compatible with coding such as .wav or .mp3. Afterward, I use audio editing software like Audacity to trim the song to exactly 10 seconds. Finally, I exported the processed audio as a new file name as Harmonic 1, Harmonic 2, Harmonic 3, Harmonic 4, and Harmonic 5. So this file showcase the original song, enrich with the added harmonics, and make it a complete and unique 10-second songs. So when we combine, it will be one song with 5 harmonic. This is the result of the second task. This clearly shows how the harmonics enhance the overall sound of the 10-second song. This is the result of the second task. This clearly shows how the harmonics enhance the overall sound of the 10-second song. This is the result of the second task.
So next I will explain about task 3. To complete task 3, we have to snap our best post team's photos. The image will be the original image. Then we visualize the original image into frequency domain using fast Fourier transform. Lastly, we reconstruct the image back to the spatial domain. So this is our coding for task 3. Firstly, we put our coding to display our original image as our figure 1. Then for figure 2, we insert our coding to display the grayscale image. For coding for figure 3, which is the Fourier transform of image, we insert the log coding. Then we insert our coding for figure 4 to display centered Fourier transform of image. And for figure 5, we insert our coding to display log transform centered Fourier transform. And lastly, for figure 6, which is the reconstructed image. So this is our result. Figure 1 is the original image, and figure 2 is the grayscale image. Then figure 3 is Fourier transform of image and figure 4 is centered Fourier transform of image. Then for figure 5, log transform centered Fourier, and lastly the reconstructed image. That's all from me. Thank you.
Next, task 4. To complete this task, we have to create a blur version of our original image using a Gaussian kernel. Then, we should observe the changes in the output image as our vary the standard deviation value, which is compare at least 4 image output with different standard deviation. Next, we should detect the edges of our original image using the Laplacian of Gaussian kernel. Lastly, we should observe the changes in the output image as our vary the standard deviation value, which is compare at least for output image with different standard deviation. For coding task 4, the step 1, we load the image. We save the photo, which is the name is test underscore photo and save as JPEG. So we save the photo into MATLAB drive, which is BERT2423, and in the document. Next, step 2. We display the original image using this code, which is refer in the reference given based on the task. Step number 3. We convert the image to grayscale. Next, for step number 4, we apply Gaussian blur with varying standard deviation, which is 1 until 4, the standard deviation for Gaussian blur. Next, next we apply Gaussian blur. Then, we display the blur image and arrange in a 2 by 2 grid. For step number 5, edge detection using Laplacian of Gaussian, which is LOG kernel. Next, we create the LOG kernel and apply the LOG kernel. We display the edge detection image and arrange in a 2 by 2 grid. Next, for step number 6, we save the process image. We save the blur image and save the LOG edge detection image. So, let's see the output. So, this is the output, which is the original image is blurred. Then, we apply grayscale image. So, at the left side is output for Gaussian blur, which is have 4 output. And we use in different standard deviation, which is the value of standard deviation is 1 until 4. Next, the right side is LOG edge detection. So we compare 4 output and we use the same value of different standard deviation.
To conclude, this project allowed us to apply signal and system concepts practically using MATLAB, focusing on audio and image processing. We performed tasks like convolution, Fourier analysis, harmonic manipulation for music synthesis, and frequency domain visualization of images. These activities enhance our technical skills and deepen our understanding of signal processing. Despite challenges like managing noise and optimizing parameters, we successfully bridged theoretical knowledge with hands on experience, preparing us for future work in this field. That's all from us. Thank you.